Hello guys, new episode here and it's hover movement. I'll just quickly show you what features do I have. Also, sample project is completely free, available via the link to the description of this video. So, once my hovercar is on the ground, I do have free cam. When I need to launch it in the air, I can have the smooth camera transition. Now I can move my car. I do have forwards and backwards movement, also strafes on the left and on the right, and with the help of my mouse, direct turns of the whole vehicle. And once I need to turn off the engine, we can again. And one more transition, and I'm in the air. So, how it works? First of all, project settings input. I share the same input as the third-person character. So simple forward and backward, left and right, pitch and yaw movement. Also spacebar for starting and stopping engine. Nothing fancy. I have custom level, and as you can see on the world settings, I have override section filled with hover game mode. So it's the simple game mode base. The only difference from default base class is that on default pawn class I do have a custom pawn. It's BP hover, this one. So particularly this level is sort of mini game. So once it's launched, it goes to the game mode, hover game mode, and start with the pawn class of my hovercar. And as you can see, I have hovercar and spring component. These two blueprints are essential for this feature. Let's start with, I'll just show you. So hover is the pawn and spring component is sync component. This sync component will be used to line trace from the mesh of our hover to the ground. Also, I have some sugar features. For instance, I don't actually care about the size and the shape of my mesh, and I also don't need to adjust the position of each line trace by my hand. They all are pre-calculated. So let's start with spring component. I do have, there are two approaches, the easy and the heavy one. This one is the complex, the heavy one. And I'll just show you the difference between this approach and the simple one. The simple approach is to lerp between two forces that should be applied to the particular location. And these forces are 0 and sort of force we need to apply, like 25,000 units. This one is actually a sort of linear gradient between 0 and 1. And actually that's the whole feature. For proper and easiest way to make the mesh to float, or I use this one in my feature for water buoyancy, but it lacks sort of controls. So with this approach I have very big dampening, and car movement is actually not as smooth and beautifully look as I want it to be, but it works. This approach here is complex one, but as you can see, it works much better with controllable damping, and it looks more realistic. So here I need to store my current force and actually check the difference between my current and my previous force that was applied one frame earlier. So what controls do I have here? I have suspension delta and suspension delta previous, stiffness, spring length, damping, and that's actually all. Force mode or force modifier is just for controlling, like, should I be line tracing or I shouldn't. So it depends whether I need to start or stop my engine. So as you can see, I do have calculate spring force. It's the pure function which calculates the force that should be applied at a particular position. So the basic graph, event tick, checks whether force modifier doesn't equal 0. It means if it's 0, I don't need to calculate anything. If it's 1, I need to do all the calculations. So one location of our scene component is the start of our line trace, and we need to line trace straight to the ground. So from this position I need to subtract these calculations. It's the up vector of our scene component modified by the spring length, the length of the line trace. And as you can see, I line trace by visibility, and let me show you how this line trace looks. So next thing is to check whether I do have sort of overlap. If it's so, here in my function I provide the distance from start and location and the normal vector. And once I calculate this force, I'll explain it in the right. I'll explain it just in a few seconds. I need to add force at location, and location is the location of our scene component. Next, I need get owner of this scene component and apply it to the static mesh component that our owner has. And next thing is to store previous delta. It's our suspension delta that we calculated this frame, and we need to store it as our previous one. So once the new frame comes, this will be new one, this will be the previous one. For calculations here, I have a spring length which subtracts the distance is the suspension delta, like the length on which we are changing position between the bottom of our mesh and the ground. So from suspension delta I need to subtract suspension previous and divide it by the wall delta seconds to have sort of dampening modifier. So damping, if you have higher values, our damping diminishing will be very fast, something like this. They're actually too high values, something like this. If you have low values, you will see that we are on sort of the rope jumping. So play around with these values. Next thing is to add the result of our damping to the stiffness of our spring component. So, stiffness, the higher value is, the more in the air from the top position our mesh will be. So, if we have, for instance, like 200 units, we will be quite low. If we have 400, stiffness is is less, so our car is higher in the air. So also play around with these values to make it look more realistic. Then we add them together, and we need to multiply it by force modifier. So this one actually, as I said, is here. If it's 0, we won't be applying any force at all. This modifier will be controlled through our BP hover. So right now force modifier is 1, right now it's 0, and 1 again. That's the whole magic. So once done with our spring component, let's talk about our hover. Let's begin with the essential setup. It's our mesh here. It is simulating physics. I do have linear and angular dampening. If I have lower values, the diminution will be very slow, and I'll have my car movement. I'll have my car force that will be applied to my car will be diminishing very long time. I need to shorten this period to make it look more realistic one. So if I have, let's go with default values, you'll see that if I apply force like this one, it's actually moving quite fast, and I am on my top. If I go with this one, I can actually go with only angular here, as you can see. Dampening actually slow off in a very short period. Also, as you can see, mass in kilos I have 50, because if I need to well, if I have mass in kilos higher than I have right now, I need to apply more force on it. So to not make very high calculations, I've gone with this value. And for instance, if I need to go something realistic like 800, you'll see that now I am stuck on the ground and I can't move. That's because there is quite low force that that I have applied. So if I go 10 times higher here, even this is not enough. And let's go with this one. Now I can move. So the higher values you have in your kilos, the more force you should apply. That's actually obvious. So quick check. Yep. Next thing is to add spring arm component to our mesh and adjust it a little bit. To make our turnability available, we need to select use pawn control rotation. Also, I do have camera lag on the rotation with the value which is quite lower than the default one. The lower value is, the more lag effects I'll have. So this one is needed to make the transition on our turns of our car a little bit more realistic. So if I don't have this one, as you can see, it turns immediately. If I have it, let's go with something like this. You can see now it turns much better. So, also camera. Nothing fancy here. Next thing is our event graph. So that's the whole magic. I guess I should start with telling you about the offsets that are actually pre-computed for our line traces. So I do have 4 line traces, but it can be expanded to like 6 or 8, doesn't matter. So it's the pure function which outputs the array of vectors. What do I do here? I store origin and box extent from my mesh, and the origin z at the bottom line. So this one is actually the height from which I will be line tracing. If I don't do this one and start line tracing directly from the bottom of my mesh, if the dampening is quite low, my line trace, my car can actually stuck in the terrain or landscape, and line tracing won't be actually happening, and my car will stuck, and the whole movement will be ruined. So to make it work, make sure that the origin from which you line trace is higher than the actual bottom line. So, and these are the computations. Left back sort of wheel, left front, and right back. So simply from origin, if we subtract the extent on x, we'll have it like, and also the same on the y-axis, we'll have it like our left back side. So think of it as of Descartes coordinates or UV coordinates. So minus minus, plus minus, plus plus, minus plus, and bottom line, our origin here, to make it yeah, on a particular height. So let me quickly show how each of them looks. So our left one, too much force is added. Yep. Okay. So as you can see, it's back and front one. Let's actually change a little bit force. Just to show you the idea. Our left front, our right front, our right back. So with this setup, you don't really need to worry about the placing the scene components by hand. And you don't need to check on the mesh size. It will be automatically correct. So once we have our array here, we can continue. So on the event begin play, as you can see, I don't have any components here. I add them dynamically. I iterate through all the offsets to add component on the particular place. So as I'm adding these components, and it's the spring component here, this one, I need to transfer the transform that we have to the relative one, and it should be relative to the our character, so our hover. So this get active transform goes to the relative 2 of make relative transform. Once I have it here, then I add this spring component to the array and attach this component to our mesh. With default settings, all is relative. Now our mesh, this car, has all components attached to it. Also, next thing is to actually on complete, I need to iterate through all of my spring components and to check whether I do have start engine activated. So if it's activated by default, it means that I launch in the air. If it's false, I'm on my ground, and then only then I should start it. Something like this. So depending on the start engine, here I'm selecting between 0 and 1 in the force that I should apply to our spring component. I'm actually changing force modifier, this one. So, and as you can see, I have the function which is called adjust force. It's in our spring component here. Actually, what it do, it's actually change the force modifier. So here, when I'm iterating through the spring list, I actually get I get all the array elements, and for each spring component, I actually change the modifier in adjust force function. So it's the basic setup here. Next thing is to actually adjust controls and our camera features. So next thing is input. As you can see, start and stop. It's for actually starting and stopping engine. So basic logic. If it's true, I need to make it false. If it's false, I need to make it true. And here I have the simple timeline with the alpha, which actually changed from 0 to 1. So this is the graph. It's the 2-second animation. 0, 0, 2, and 1. I store it as the engine alpha, and for each spring components, do the same as I did here. Engine alpha is from 0 to 1, and it's slurping. If I have 0 in engine alpha, it means that I should go with 1 here in adjust force. If it's 1, it means that I should go with 0 here. I need to deactivate my engine. So, and once I press start engine, it's playing animation. If it's need to switch it off, it's reversing it backwards. So that's it. Next thing is the forward and backward movement. Also strafes on the left and on the right. So here from get control rotation, it's our pawn I break it and make new rotator on the yaw, and from this one I need to get forward and right vector, modify on the values that I have on my input axis, events, and multiply by force to add. So I do have 35,000 units added added to the mesh. So, and as you can see, I don't need to change acceleration boolean, because if I do have it, the mass of my mesh won't be taken I forgot the word. So yeah, as I said, mass will have no effect, and so actually this will contribute to very big amounts of force added to the mesh. So next are two controls: simple pitch and yaw inputs for our look up and turn ability. As you can see, it's the same as the default third-person character preset. It's nothing fancy, it's obvious and common controls. Then on the event tick, here I do have the following functionality. I check whether start engine is true or false. If it's true, I check whether camera turn is finished. It's the boolean which I need to actually change during the animation of the, like, when my car is standing on the ground and I need it to start floating, to move it to the air. I do have the smooth camera transition from, like, as you can see right now with my mouse, my mesh is actually turning to the direction of where I am turning, and right here it's the free cam. So once I start my engine again, I need to switch the position of my camera from this point to the position where my mesh is looking at, to this point. Good. So that's the animation that I have here in this particular timeline. So if I don't have camera turn finished, I need to play turn animation. If my turn animation is complete, I need to change the rotation of my mesh, of my car, of my hover, and how it actually changes. I have interpolation on the rotators between the mesh rotation and camera rotation. So I set volt rotation of my mesh with the yaw input from the camera, but with the roll and pitch controls from my mesh. So it's the custom rotator. And interpolation here actually makes the movement a little bit smoother. If I have like one here, as you can see, I'm turning quite low, flow values. If I have it like 10, transition will be much faster. And I don't need to have controls with my mouse changed on the roll and pitch, so they are the same that the mesh is. So this one helps actually mesh to align on the surface which I am moving at which I am moving at. So, and if engine engine is sorry guys, start engine is false, I need to reset turn animation. And reset turn animation actually do quite tricks. So, because these events, play turn animation and reset animation, I actually checked every frame, but I don't need to actually change like variables of my spring components and other stuff every frame. I only need to do this once to play animation and then go back with like this functionality. Only change rotation on the every frame. So that's why I do have some sort of more complex logic here. Play animation. Here I do once, and then I'm switching off pawn control rotation on my spring arm. The reason is quite simple. If I don't do this, that's how the animation will look. It works fine, but I don't have, right now I'm trying to manipulate with my mouse and nothing happens. Also, yeah, one more thing. That's the bug. So, if I do have control rotation applied to my spring arm, and I don't actually switch it off, no animation will be applied, and only the car mesh direction will be changed to the camera changed. So to make it work, I need to switch it off here and apply again here after animation is complete. Also, I do need to set control rotation to the default to actually the particular world rotation of my mesh, because if I don't do this here also, animation will work fine, but as you can see, I have sort of lag here, because once this is turned off, mesh rotation actually, not mesh, pawn rotation actually is stored, and because I don't override it, it's trying to actually go back to its previous position. So that's why I need to set control rotation of my controller, of my pawn, to the position of the current mesh rotation. Then camera turn animation, also 2 seconds, simple timeline, from 0 to 1, and I played it from the start. I store it as the turn alpha, and here I'm setting world rotation of my spring arm. That's essential, because if I change the position of, not the position, the rotation of the camera, you'll see that animation works in a less accurate way. But actually it's up to you how to go with. I actually like to change the spring arm. So it's linear interpolator on the rotators. So from camera rotation to the mesh, depending on the turn alpha. If it's 0, it's camera rotation. If it's 1, it's mesh rotation. So simple. When the animation is done, I need to turn on the pawn control rotation and change camera turn finish. By default, start engine and camera turn finished are set to true. also important. So if it's positive, then this one will happen. If it's negative, we'll be playing our animation. And then here I need to actually reset turn animation. So when I'm trying to like switch off camera turn, I also need to do this once. I don't need to trigger this, changing to this variable more often than once per action. So that's like if I don't have do once here, I have it here. This one will be triggering every time. If I start engine going up to false. So I need to limit it like this, and I need to reset it once the animation of start engine is complete. So play turn animation, do once. Animation is done. On finish, we need to go and reset the whole cycle here, which actually will reset the play turn animation. So one big loop here, here, from here to here. So I guess I showed you everything, and I guess I explained everything in a quite good way. So guys, I hope you like this tutorial. Please subscribe, leave your feedback. I do have a Discord channel, also Patreon if you want to support me, and see you soon.